Hi, I'm Mr. V. This is Illustrative Mathematics. We're in Geometry, Unit 6, which is Coordinate Geometry, and we're looking at the types of transformations. And by the end of the period today, you should be able to say, I can determine whether a transformation produces a congruent or a similar figure or neither. And that's the big idea. So we start this activity with some stuff that is it's really self-driven. It's really self-directed and self-checking. So this is not meant to be demeaning or elementary, but it's pretty basic level that these three would be the same. And you can drag this to verify that. So I can move this here, I can move it here, and I can move it here. Yep, these are all the same. This is not the same. And we move on, we say, well, what are the coordinates? And so if you're going to apply this, we're going to go 5 units up, 5 units to the right and 3 units up. We're going to add 5 to the first term, so that'd be 6. I'm going to add 3 to the second. So for the second one, if I add 5 to 3, I get 8. And I add 3 to the second one, I get 4. If I add 5 to 3, I get 8. And if I add 3 to 2, I get 5. So 5 to 2 is 7, and this would be 5. And I get 5 to 2 is 7 again. And if I add 3 to 4, I get 7. And add 5 to 1, I get 6. And 4 plus 3 is 7. And now when we submit this, watch what happens. It all moves together because I did the coordinates. And you could do this every time like this, but there's an easier way, and that would be to write the rule. So for example, if I write x minus 2.5 and y minus 1, you can see that this is going to be a transformation, a translation, a simple translation, and it moves like that. Now, can you match each one of these? Well, sure you can. Let's go to the red one. From the black to the red, I'm going to go 3 to the right and up 1. So I will go x plus 3, comma y plus 1. 3 in the x direction, y plus 1. And that's the rule. And that's what we're doing, is getting some used to writing the rules. These are all translations. The only one that's tricky here is going to be going to the one that's the purple one here at the left. What's going on with that? What is staying the same? I'm going to go, my x values are just going to stay the same. But what's happening to my y values are going to stay the same. So comma y. What's happening to the x values? It's changing. It's going to be from positive, it's going to be negative. So it's going to be the opposite. So I'm going to try it like this and see what happens. You can see what happens. As opposed to changing both of the signs, if I went negative x and negative y, what would that look like? Well, that's going to go 180 degrees. Or if I changed the y and I went from the same x value, but I changed the y values, that would be flipping it across the x-axis. Well, it's flipping across the x-axis. Why does the y change? Well, because the x stays the same. Here, we're going to read the instructions and follow them carefully, please, when you do this. You're supposed to plot point P at 0, 0, point M at 2, 0, and point N at 6, 0. And draw segments P to B prime, B to M, and B prime to N. And notice we have 2 right triangles, both following along the grid. And we both have this angle here in common, which means that by angle-angle similarity, these 2 triangles are similar. And if you look at the next page, how do they compare? Well, they're similar. The one is going to be 3 times in length as long. If you look at the areas are going to be 9 times as many. If I could draw 9 of these triangles in here, I should probably do that just to show you. By area, this goes with our scale factor squared. So the scale factor is 3. Notice I can fit 9 of these triangles in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of these triangles. So by the scale factor is 3. So that means that this distance here is going to be 3 times as long. So how did these PB and PB prime compare? This would be 3 times as long. It's going to be a 1 to 3 ratio. And there's a short video here which synthesizes this and explains why. And on this page, you'll notice that if I scaled both the x and the y, that would be a dilation. So it's going to give me a scale factor of whatever it is that I'm multiplying them both by, with 3. That makes sense, doesn't it? If you don't have a copy of the reference document, you can make a copy of it here. In the reference document, it says a dilation is the factor or scale factor by which every dimension in an original figure is multiplied when you make a scale copy. So if I take the radius of 0.5, multiply it by 2, I get 1. And that's what we're doing with this business of multiplying both the x and the y by 3. Here's a card sort. If I were doing this card sort and I were you, I would put them into different categories. This one's kind of weird. It's going to go multiply one of them by some number. Here we're multiplying both by the same number. This one's changing the sign. And this one's just adding and subtracting. This one's going to be a simple translation. I'm going to look at this one. This is a simple translation. So it'll go here. One that I'm multiplying by something by, let's see, this one's getting larger and smaller, or smaller. So I'm multiplying both by the same thing. It's the same shape. These are not the same shape. They're also in different directions, but they're not the same shape. So when I multiply one by a number and I don't multiply the other one by the same number, I get something that is stretched in one direction. And this one is kind of weird. It's a rotation. Well, notice we switched the letters and we changed the sign of one of them. But the value of x and y are not multiplied by a multiplier except for negative 1. And that's what does the business of either reflecting it or rotating it. These two are both translations. They are congruent. This one is a dilation, and this one is neither. There is a more activity which you can do if you feel up to it. In the synthesis, we talk about these angles. Here, you get to write the rules. Looking at these two to first, are they congruent? No. Are they similar? Well, they're both in the same x direction, but not in the y direction. So these are neither. And if we were to write a rule to come up with this, let's see. The rule would be my x values stay the same. So when I map this first coordinates to the second, the x values stay the same, and the y values are doubled. So I'm going from 3 to 6, and I'm going 4 from the x-axis to 8. So I'm doubling it. And that may be a little bit tricky to see. In the second one, how do we map it? Well, it's a reflection across the x-axis. And yeah, that's true, it is. And what stays the same? The x values stay the same. The y values are going to be the opposite. So I write it like this. Can you tell me what would this transformation bring? This means that no matter what point I had, if I started with a triangle or if I started with something else, I would always go to -1, -1. So this would not be a rigid transformation. They would always go to that point. That's like not very nice. To be a rigid transformation, it has to, and the figures would be congruent. I'm going to have some letters x, comma y, and they're going to be mapped to when I have an x, and it could be a plus or it could be minus, but it's some constant, or a y, and it could be a plus or a minus or some constant. And we'll call that h and k. And they could be different constants. I'm going to either move it horizontally or I'm going to move it vertically. Also, if you change the sign, so this would be a translation. If I were going to change the sign, say I'm going from x, comma y to I'll change one of the signs to x, comma -y. This would be a reflection. Now, which one is it going to be across? If the x values stay the same and the y values are different, that would be across the x-axis. The x-axis. Can you imagine which one it's going to be if it's for the y-axis? That would be if you changed the y. And if you did a rotation, so you have translations, we also have rotation, reflection, which is what this one is, or a rotation. These are our 3 rigid transformations. A rotation would be if you were to, say, change a -x and a -y, or maybe you switch the values and change one of the signs. Switching the values alone would also be a reflection across the axis, across the line y is equal to x, but that's for another day. So there's three rigid transformations: translation, reflection, rotation, and they would make congruent figures. If I'm going to get a similar figure, I'm going to multiply both of these by some scale factor. We call our scale factor k before, unit 5, so we'll do that here. And if it's neither, that means I'm going to be multiplying these by different numbers. Maybe only multiply the one but not the other, or maybe multiply it by something else. So this would neither be a similar nor congruent. There is an activity synthesis and a lesson synthesis for you to read. In the lesson synthesis, this is an important activity. Here, if you can understand this, you would recognize it right off. I'm going to start with the dilations, and we'll do this one in, do I have different colors? I don't have different colors. The dilations would be where I'm multiplying it by the same factor every time. So this would be a dilation. Down here, this would be a dilation. And I think that's the only one where I'm multiplying by the same thing. If I'm multiplying it by something that's different each time, so here I've got one that's neither, put an N there. This one I'm multiplying by something that's different for each one. Yeah, -1 doesn't count. -1 is going to be, it's still going to be just the X. So here I've got 3 of these. These last ones, I'm adding to both sides. That's a transformation, adding or subtracting to both sides, moving it in the X direction or the Y direction. Here, we're changing this. This is going to be a reflection across, let's see, if the Y value stays the same and the X value changes, that would be a reflection across the Y axis. That would still be a congruent. And here we're doing the opposite. We're just changing it across the X axis, so this would be congruent. This is going to be a rotation all the way around, and this would also be a constant. So if it's a negative X or positive X, and you're not multiplying it by anything except a -1 or 1, then it's going to be congruent. The lesson summary. For the cool down, you don't need to write to carry out the transformation, but you should write one here. And you need to have an X in here, and it's not going to be multiplied by anything. So you could put it a plus something, maybe a +1. You're going to have a Y in here, but it could be a negative Y. It could be a negative Y. That would still get you there. To be congruent. To be something that is not congruent, well, but similar, you have to multiply both the X and the Y. So you have a scale factor to do this. And that would be what's important here. And finally, there's a gallery where you can make up a challenge and you get to try it out. And you can add it you can add up a transformation that you think is good. Like if I do 3x and 3y, and then it carry it out. This is really cool. See what happens? It gets larger. And that's pretty much today's lesson. So good luck and success.